Hi, I'm Professor Goins. In this video, I'm going to look at quadratic functions. In particular, how do we find the range of a quadratic function? All right, so first and foremost, let's look at the two possible shapes of a parabola. Obviously, you can have horizontal shifts and stretches and things like that, but generally break them into two categories where they open upwards or they open downwards. And in either case, the range is going to depend on two things. One, the vertex, in particular the y-coordinate of the vertex. Notice that in this case, the y-coordinate of the vertex is the smallest value of the range. Over here, the y-coordinate of the vertex is the largest value of the range. One thing I do have to find then, of course, is the y-coordinate of the vertex. The other thing I need to determine is which way the parabola opens. Does it open upwards or does it open downwards? Okay. If I look over here, this is going to tell me that information. I'm going to look at quadratic functions in standard form. You can also find the same information in general form, and I'll do one of those down here, but I will find it by converting it to standard form. So I'm going to put everything in standard form. Okay. Standard form means I have it written as the result of completing the square. And this is the version of the quadratic function that's easiest to see how to graph it, because you can see the horizontal shift, a vertical stretch. You can see all that information. Okay, anyway, the vertex is given by the ordered pair h comma k. So it's the opposite sign of this number is the x-coordinate of the vertex, and then this value right here is the y-coordinate of the vertex. So again, the y-coordinate, the k value, is what I'm in particular looking for. There I use k for the y-coordinate of the vertex. Here I use b, but again, it represents the same thing. Simply because when we do standard form, it's traditional to write this as a, h, and k. All right, so which way does it open? Well, standard parabola is y equal to x squared. If I shift it upwards, shift it over, the leading coefficient is going to be, say, positive 1. In order to accomplish this shape, what I have to do is a vertical reflection, which means I have to multiply the base function by a negative. That tells me that the leading coefficient a is positive here and a is negative in this case right here. So really all I need to know is two numbers. What is a and what is the sign of it, and then what is the value for k. All right? Let's go through some examples here where we'll find the range of a function. The first two are given in standard form. The third one is given in general form. So let's go ahead and see how this works. Okay, so for part A, the range. The leading coefficient is positive, so that means that the graph opens upwards. The y-coordinate of the vertex is 5. Therefore, I know that the vertex y value giving me 5, the parabola opens upwards, says that the range is from 5 to infinity. Okay, so it opens upwards, that means it has a minimum to it, and the minimum is the value of 5. And that is included because the vertex is actually a point on the graph. Part B. Okay. This one, the parabola opens downwards because the leading coefficient is negative. That means it has a shape like this. And the y-coordinate of the vertex is at -6. So that means that minus 6 would be the top of the graph, the y value corresponding to the top of the graph, so it would be that negative 6, and then everything below. Therefore, the range in this case would be minus infinity up to negative 6, and including negative 6. Okay. Finally, for part C, what I have to do is I'm going to convert that to standard form. And to convert that to standard form, remember we used the technique called completing the square. If you don't remember how to do completing the square, I'll work through it right here, but we also have a video explaining that technique. So let's go through and complete the square. As a reminder, if the leading coefficient when you complete the square is not a 1, you have to start by factoring that out. That would give me by factoring that out, what that means, I divide the remaining terms by 2. This would cancel the 2. 6 over 2 is 3. 1 over 2 would just give me a half. Inside the square brackets, then, I can complete the square. Which, as a reminder, what I do is I'm going to add the coefficient of x, which is 3, divided by 2, squared. Then I subtract the same number, and then I've got the minus 1/2 there. So I introduce these two terms right here, which of course add to 0, so they are really keeping it balanced, but I have to choose these specific values. Then what happens is the first 3 terms factor as a perfect square, and it turns out to be x plus 3/2 squared. So this 3/2 comes from this number right here. Again, if you don't remember the technique, if you're not familiar with it, go back and watch that video. And then I've got minus 3/2, so I evaluate the last 2 terms. If I square 3 over 2, that would give me 9 over 4. So I would have minus 9 over 4 minus 1/2. Combine those 2 terms here. Of course, 1/2 is the same thing as 2 over 4. That would give me 11 quarters, because 1 over 2 is the same as 2 over 4, and then minus 9 minus 2 would be minus 11. And then the last, the last step, I take the number that I factored out, I have to distribute it back through to get 2 times the quantity x plus 3 over 2 squared, and then 2 times negative 11 over 4 would give me negative 11 over 2, because 2 divided by 4 would leave a factor of 2 in the denominator. All right, now I've got the information that I need. Leading coefficient is a 2. Of course, we knew that from the very beginning, meaning that it opens upwards. And then I have the y value of negative 11/2. Therefore, for part C, the range of this quadratic would be including negative 11/2 and then everything up to infinity.